So, today we're starting to learn calculus. What is calculus? Calculus is the mathematics of change. It is a mathematics of change. So, let's consider, for example, function y equal x squared. Where is it? F of x equal x squared. If you sketch its graph, it's parabola. And we have some points, 1, 1.
Oh, it's a parabola.
2, 4. And so on. Let's find average rate of change of this function between values of x equals 1 and 2. So how we finding average rate of change of the function?
You have to use calculus.
No. Average rate of change. So that will be, what will be the change? How we find the change? We do value of function at 2 minus value of function of 1 at 1 over, because we're looking for rate. So we're looking how much function changed over the given interval, which is 2 minus 1. That's how we find it. Yes?
Why is the interval just
We said the interval from 1 to I can.
there and there?
Yes. So effectively what we're doing, we're replacing this parabola on this interval with a straight line connecting these 2 points. And we're finding the gradient, because gradient is the rate of change. Gradient telling how fast the change happens. So obviously this case it's equal 4 minus 1 divided by 1 equals 3. So average rate of change of the function x squared on the interval from 1 to 2 equals 3.
Oh, it's,
Average
that
rate
makes
of
sense.
change. Now, let's make interval smaller. Let's make interval from 1 to 1.5. To 1.5. 1.5.
Oh, that changes
So
things.
we have now point 1.5, 2.25. Because 1.5 squared is 2.25. And sorry, point is on the parabola. So that will be the new second line connecting these 2 points. And now rate of change on the interval from 1 to 1.5 will be equal f at 1.5 minus f of 1 over 1.5 minus 1 will be equal 2.25 minus 1 divided by 0.5. 1.25 divided by 1.25 divided by 0.5 equal 2.5.
When it's divided by half, you times 2.
We dividing change of function of y over the change in x.
Yeah, but I should remember that.
If we will, rise over run, yes, it's a gradient. Rate of change
Divided by 1 over 2.
is a gradient of this. If we will be making this interval smaller, smaller, and smaller, from 1 we'll be getting second point closer, closer, and closer, and we will get, eventually, we will get to what?
0.
To tangent. This second line becomes tangent
To the,
at the parabola at the point 1. And that will give us, gradient of this tangent, will tell us instantaneous rate of change at the point.
Okay.
rate of change at the point. Now, do you understand how to find average rate of change
Yes.
between 2 points?
Just the gradient.
Just a gradient, if you connect these 2 points with a straight line, points on the graph of the function, and you find average rate of change.
Yep.
Make sense? Average rate of change. To find instantaneous rate of change, we need to draw a tangent and find gradient of this tangent. We will not be doing that graphically, we will soon learn how to do it mathematically. Pretty much what we did now, we covered all of the chapter 16.
Great.
Yes, we pretty much covered all important stuff from the chapter
This is the
16.
booklet says 17, 18, 20, and 21.
No,
Yeah,
but
no shit. What are you talking? We got 2
It's
weeks.
5 chapters.
Are you,
we
are you
have more.
like-
We have more. Yeah, we have more stuff will be later than say.
No, but it's just
I don't
it's
know.
just a stupid thing.
So that is
I
pretty
don't
much.
know, what is wrong with it? We did 1 chapter in 1 day, and we have
So-
5 chapters left for 2 weeks. How does that? What's wrong with it?
Now, to understand the calculus, we need to introduce the new idea of limit. And to understand idea of the limit, we need to understand idea of the approaching. So if we have idea of the approaching, if we have, for example,
I don't know.
we have again function f of x equal x cubed. And if you sketch this graph,
It's very big.
and that will be point 1, 1.
Wow.
So this is the graph of the cubic function. If x will approach in 1, so we come in from this side, we come in closer and closer to 1. So we're moving on this graph, we're moving closer to this point. So when x will be approaching 1, what value of y will be approaching? 1. Does it make sense? What does it mean approaching? When x approaching
Getting
something?
closer to.
If we will have another example, if we have f of x equal sine x. If we will have x approaching pi on 3, what f of x will be approaching? X approaching pi on 3. What sine of will be approaching? Will be approaching root 3 on 2.
Oh, that makes sense.
Just exactly
This is just the thing.
When we come in on the sine graph, closer and closer and closer, x coming to pi on 3,
Yeah.
y coming closer and closer to 3.
Okay.
So what is the limit? Limit is a notation limit. And let's say f of x when x approaching a. This is a notation for the limit.
Huh?
This is called limit.
Notation.
Notation limit f of x. So this question asks, what value function approaching when x approaching some value a? Yes.
I was just going to say, so that means what is f of x approaching when x is approaching a?
That's
what-
exactly.
Yes.
Yeah, I know.
What is y
That's what I was
approaching?
going to ask.
Yeah. Good. What is y?
It's not a stupid
So
question for you.
if function
differ.
if function is defined at at
Oh,
a,
he's not wrong.
then this will be
100%.
equal f of a, value of the function at the point a.
Yeah, not wrong.
If x approaching a, value of function approaching to value of function at a. For example, let's consider f of x equal 2x squared minus 3x plus 5. So let's find limit this function f of x when x approaching 2.
Oh.
How we find it?
2 times.
We substitute 2 instead of x,
Yes.
so we get
Minus
8
6.
minus 6 plus 5 equals 7. So limit f of x when x approaching 2
Oh.
equals 7, because when x approaching coming to 2, function coming
But I'm
to
also wrong because I
7.
started doing it and you also wrong.
make sense?
Yes.
Yes.
So you just, if function is exists at this point, we just substitute value of x, this value, into that function.
Oh, have we done? Is this chapter 17?
Make sense? What is limit?
Yes, that makes sense.
What if the function does not exist at the point? What if the function does not
Do it
exist
again.
at the that point? So, let's consider function f of x equals 1 on x.
Oh.
F of x equal 1 on x. And rectangular hyperbola, you all should remember this graph very well.
It's a truncus.
It is it's rectangular hyperbola. Truncus is 1 on x squared.
Yeah, because it's square. Yeah.
Yeah, so it can't
So
be-
this is
That's the whole thing.
Hey, you don't go
This
for it, you don't
is-
do steps, okay?
function which is not defined at x equals 0. So, what will be limit of f of x when x approaching 0?
Mr. V,
Infinity.
that's not
No,
possible.
it doesn't
Doesn't exist.
Why it doesn't exist?
One can't divide by zero.
Shh, one by one. Why it does not exist?
You can't divide stuff by 0.
It's an asymptote.
We're talking about
Who said
approaching.
what? I'm not-
Now, why? No, it's actually this limit does not exist, but it doesn't exist only because if we're approaching from the right, what function approaching to?
Infinity.
To infinity. When we're approaching 0 from the left, negative infinity, which is not same thing. But if I will put it x approaching 0 and I will put plus here, that will means we're approaching 0 from the right. What function approaching? Infinity. So this limit equal infinity.
But you can't
Because
divide by
yeah, you
zero.
cannot divide. It's approaching. It does not equal, but it's what it's approaching. When x coming closer to 0, it's approaching infinity. Now, what will be limit of the same function when x approaching infinity? When x approaching positive infinity, what? 0.
One of my biggest.
It is equal 0. Will function ever equal 0?
No.
It's approaching it.
But it's approaching 0. And as bigger we take x, the more close it's approaching to 0. So this limit exists. Even function does not exist. Sorry, we cannot say what the number, because when we approaching x approaching infinity, y approaching 0. It's never will be 0, but it's infinitely close coming to 0. Make sense?
Why is it possible to do the 0 positive and not the 0 negative? Why is it
Is 0? You mean here or here? Top one.
Yeah.
That means it's not positive 0. It means we're approaching to 0 from the right, from positive side.
Can you
It's
write-
not positive 0. It's same 0, but we're approaching. If we will approach 0 here, limit f of x when we x approaching 0 from the left. If we will approach 0 from the left, what function will be approaching?
Negative.
Negative infinity.
But can't you write limit f of x when x is approaching 0?
That does not exist, because if we approach from the right, It's to positive infinity, from the left to negative infinity. For limit just approaching zero exists, it has to be say they should approach
Okay, that makes sense.
Now, let's consider one more function. Let's consider the function f of x equal x squared minus 2x plus 1 divided by x minus 1.
What's the limit?
Now, my question is, does this function exist at x equals 1?
No.
No. But if you want to, it does not exist, because then we'll get 0 in the denominator. If we actually simplify this function, this is x minus 1 squared over x minus 1, we get x minus 1. We just simplified this. X squared minus 2x plus 1 factorizes to x minus 1 squared.
Wait, the what is going to make sense in a few seconds. Just wait.
Now,
Yes, it will.
and if you sketch this graph, y equal x minus 1,
See, now it makes
so
sense. 'Cause the limit is
y
That's why I
x,
said what. Exactly.
this is the graph of the function x minus. Does this will be correct graph of the original function?
That's why I said what.
Why will be this graph correct graph of the original function?
Yes.
There's supposed to be a hole at x equals 1.
Correct.
So you just
It's not correctly represent this because this function does not exist at x equals 1. There will be a hole in the function. It's not this function not defined at x equals 1. So in the line we will have a hole. It does not go through that point.
So it's just that point, there's nothing there.
Yeah.
Okay.
Is that how you draw it?
Yeah, you just put a open circle means not
If
included.
you do a closed
Now,
circle, it means
what will be if I will put now limit of this function limit
X approaches 1.
when x approaches 1. If x approaching 1, what this function approaches? 0. So limit exists. Function does not exist, but limit exists because it's does this approaching to 0? Does y value approaching 0? When x coming to 1, does y value coming there? Yeah. From this side, we coming x coming to 1, function approaching 0. So when x approaching 1, y approaching to 0, it cannot be equal to 0, but it's approaching 0. That's what limit means. It's approaching.
yeah.
And now we are ready to introduce derivative. To introduce derivative.
My sister loves that.
To introduce derivative.
Rap.
Yes, you.
Never mind. Okay.
And definition. Now, there are two notations for the derivative.
Where's my pen gone?
If we have y equals f of x, some function, there are two notations for derivative. It happens historically because calculus, differentiation, was invented by two people pretty much at the same time independently. One was Newton. You see, Newton contributed a lot to not to just to physics, to mathematics as well.
Really?
Another was German mathematician Leibniz. And they used different notation for the derivative, which they invented. And so historically both notation hold up to today and accept it. So you can write it's either f dash of x. This notation means derivative. Or we can write dy over dx. I think Newton used this notation, Leibniz used this notation. I might mix it up.
What's your favorite notation?
There is no favorite, sometimes using one, sometimes using another. There is no difference, you're absolutely fine to use any of those, they're equivalent, it's same thing. And now definition. If we have x and then we have another value of x plus h some number. X, we have original some value of x. Then we take another value of x plus h. We added some number. So we have value of y will be f of x. Here will be f of x plus h. First, let's find average rate of change. Average rate of change between these 2 points. How we find average rate of change?
y2 minus
y2 minus y1, so we have f of x plus h minus f of x
What's the interval?
divided, what the interval? X plus h minus x, h. So that will be average rate of change between these 2 points.
That's true, become graph.
Now, if we will now make h as small as possible, we will come to derivative. So it is limit change of function over change of x when change of x approaching 0. Then when we take this interval, as we did with the graph x squared, we will closer to 1, we get to the tangent line. And this is the definition, strict mathematical definition of the derivative.
H is approaching 0.
What's it called?
Let's use this definition and to find derivative of function y equals x squared.
Bet.
And finding derivative in this way called differentiation by the first principle. It's usually not used in unit 3-4, but in unit 1-2, yes. So, if we have f of x equals x squared, what is f of x plus h equal? What is f of x plus h equal? If function
Plus h squared.
will be x plus h squared, let's expand it. X squared plus 2xh plus h squared. What will be, now let's find limit of f of x plus h minus f of x divided by h when h approaching 0. We have f of x plus h equal, so we have limit h approaching 0, x squared plus 2xh plus h squared minus x squared divided by h equal limit when h approaching 0, limit of 2, and then we divide, x squared is cancels out, and we divide by h, so what we left?
X plus
2x plus h.
Oh, yeah, x squared. X squared.
Now, how we find the limit? We substitute
F of
where
equals 0.
h equals 0,
2x, so it's 2x.
equal to x.
Oh, yeah, mamash.
So that is derivative of the x squared. So derivative of x squared equal to x. That we have found it using first principle. Now, let's do little bit complicate the task. Let's make function. No, we will still will be doing the same thing,
I don't get what everyone's.
but let's say function is
Because no one expected.
f of x equal x squared minus 3x plus 1.
Okay.
Let's find f of x. Let's find f of x plus h. Let's find f of x plus h.
Thanks, man.
How we should do that?
You remembered. I didn't expect that.
X squared minus.
We
3x
substitute
plus
instead of x, what we should substitute? X plus h. So equal x plus h squared minus 3 times x plus h plus 1. Expanded x squared plus 2xh plus h squared minus 3x minus 3h plus 1. Then what will, let's find the derivative. So limit of f of x plus h minus f of x over h when h approaching 0. So we need subtract do this minus f of x. We have limit when h approaching 0 of x squared minus x squared gone. Minus 3x minus minus 3x gone. 1 minus 1 gone. So this gone, this gone, and this gone. What's left? 2xh plus h squared minus 3h. Dividing by h, we get limit of h approach. Does this make sense how I got this? I subtracted fx plus h minus f of x. If this minus this, x squared will go, minus 3x will go, and 1 will go. And that's what's left, 1, 2, 3. Then we divide in by h, we get 2x
plus h.
plus h minus 3.
So the limit's 2x.
Substitute h equals 0, what we will get?
2x minus
2x minus 3. 2x minus 3. So that will be, we found derivative of this
That's why
function
I love maths.
using the first principle of the differentiation.
So the derivative is 2x
They don't have to
minus
understand it.
2x minus 3. Now,
That's also why chemistry is tough as well. And physics.
now, does, okay, before I will add a couple more things, does it all make sense what we did? Now, let's try to make some generalizations.
Isn't it the coefficient of the?
I'm not practiced.
Am I right?
Yes, some generalizations already start happening. So, if we have, what if function f of x equals c, constant number, 5 or 3 or minus 5, whatever you want. What will be derivative of this function? If function 0, why it's 0?
Because it's just a line like that.
Is it ever changing? No. What will be the rate of change if it's never changing?
What the hell is that?
Graph, let's say c equals, let's say 5. The graph will be,
Yes.
and this is 5. What is the rate of change of this line? What the gradient of this line?
0.
0. So derivative of the constant will be 0.
Okay.
That's why when we did this, nothing left from 1. Because derivative of the number is 0. Number does not change. Now, what we get as derivative of x squared. We did twice it, so what it's equal? 2x. Derivative of x squared equals 2x.
Limit of the rate of change.
If we
Yeah, that's what it is. It's the limit
If
of the-
we will do the same thing for x cubed, we will find the derivative of x cubed. Using the first principle, we can show that it will become 3x squared. Can we now deduce what is the derivative of x in the power of n?
Yeah.
Yes.
NX with
To the power of n minus 1.
Yes. So when we differentiate power function, power coming at the front as a coefficient, and power dropped by 1. So that is one of the very important formulas for differentiation, derivative of the power function. Another, if we have another important properties of the derivatives, if we have two functions, f of x and g of x, then derivative of f of x plus g of x, and we can put it in the bracket and put dash, that means derivative will be equal just f dash of x plus g dash of x. Or if it's minus, it will be minus.
What? Yes, that makes sense.
So the derivative of all that is just the derivative of each one.
Yeah, and we add them or minus.
Okay.
Now, from the example that we did, what will be derivative of, let's say, 3x? Oh,
3.
will be 3. We just did it.
Yeah.
Derivative of 3x will
Yeah.
be just 3. So, derivative of kx
Okay.
equal just k. Because what will be derivative of x?
1 here.
Okay.
0.
X in the power of 1.
Goes 1x.
1 come at the front,
One.
1 minus
Yeah.
1, 0.
Yeah.
So you have 1 times 1 is 1. Derivative of x is just 1. So this equals 3. If we have derivative of, okay, I think that's enough for today. So now we have 10 minutes to start practicing. With that,
Thank you, Mr.
like,
J.
subscribe, and donate to help fight terrorist countries and organizations, Iran, Hamas, Russia, etc. Support Ukraine and Israel.